Hello friends, today's session we are going to talk about surds. So let's first begin with understanding what are surds. Surds are irrational numbers which are represented as nth root of a positive rational number. So let's see how do we represent them. A raised to power 1 by n or nth root of a. So this is called a surd if it is irrational. So the important condition here is that this number has to be irrational. So supposing we write a number of the type 8 cube root. Now since this is equal to 2, which is a rational number, so cube root of 8 is not a surd. So surds are only the irrational numbers represented as nth root of a positive rational number, and these surds are also called radicals. So examples are cube root of 5, fourth root of 8, and so on. Now when we represent the surd as nth root of A is called the radicand and n is the order of the surd. So we say this is a surd of cube root of 5 is a surd of third order. Fourth root of 8 is a surd of fourth order. And surds follow all the laws of exponents. So now let's talk about the different types of surds. So the first are the pure surds. So the surds which have no rational factor other than 1 and have all the irrational factors are called pure surds. So we take an example of cube root of 2 or fourth root of 6 and so on. So if we take an example, say fourth root of 6, this can be represented as fourth root of 2 multiplied by fourth root of 3. So we know that the factors of fourth root of 6 are just 1, fourth root of 2, fourth root of 3 and itself, which is fourth root of 6. So it has only one rational factor, which is 1. So that this is a pure surd. Next we come to mixed surds. Now the surds which have at least one rational factor other than unity. So other than 1, it has at least one more rational factor and other factors being irrational. These kind of surds are called mixed surds. So we take an example of 2 into cube root of 5 and 6 into cube root of 7, and there could be many more examples. So in this, if we take an example of 2 into cube root of 5, we see the factors are 1, 2, cube root of 5 and itself. So this means that besides 1, it has 2 as another rational factor. So such surds are called mixed surds. Now there are quadratic surds. What are they? The surds of second order. Second order means the power is 1 by 2, which means square root of the numbers like square root of 3, square root of 10. These are called quadratic surds. And these quadratic surds having two terms separated by a addition or subtraction are called binomial quadratic surds. The examples are root 3 plus root 5, 2 minus root 3, etc. So these kind of surds are called quadratic surds. Let's see how do we do a comparison of the surds. If the surds to be compared are of the same order, say for example we have to compare nth root of A with nth root of B. So we are saying order of these two surds is the same. It is n in both the cases. So these can be simply compared by comparing their radicand, which is A and B. So if we compare A and B, if A is greater than B, then nth root of A will also be greater than nth root of B. So say for example, we want to compare cube root of 5 and cube root of 9. Since 9 is more than 5, so we say cube root of 9 would be more than cube root of 5. But if the surds have different orders, the surds to be compared are of different order, then we first convert them to the surds of same order and then compare them. Let's see with the help of an example. Say for example, we want to compare cube root of 2 and fourth root of 3. Now the order of these two surds to be compared is different. It is 3 in one case, 4 in one case, so we can't directly compare them. Now what do we do is, we take the LCM of the order, which is 3 in this case and 4 in this case, which comes out to be 12. So we convert these two surds to 12th order surds. So cube root of 2 becomes 12th root of 2 raised to power 4, and similarly 4th root of 3 becomes 12th root of 3 raised to power 3, which is nothing but 12th root of 16 and 12th root of 27. Now looking at the radicand, we can see 27 is more than 16, so 4th root of 3 is greater than 3rd root of 2. So now we'll talk about rationalization of surds. When surds occur in the denominator, we change the number to remove the surd from the denominator and we bring it to the numerator in some way without changing the value of the given surd. So this process is called rationalization. Now important thing is that we don't change, we somehow bring the surd to the numerator and remove it from the denominator without changing the value of the given surd. Why is this required is simply because it eases the calculation and simplification of the expressions. When we have a surd in the denominator, and if we have two expressions or more expressions and all of them may or may not have the same surd in the denominator, it is not very easy. It is not going to be very easy to calculate and simplify it. So to ease that calculation, we do the rationalization of surds. The numerator and the surd in the denominator are multiplied with an expression such that the product in the denominator is a rational number. So the process of doing the rationalization is, say we take a general fraction of the type a by b. If we want to do anything with this, any operation with this fraction, with this rational number, what we do is that we will multiply it in the numerator and we'll multiply the same thing with the denominator, so that the net value of this fraction does not change. It still remains a by b. So we take the same approach. We multiply the surd in the denominator with another surd in the denominator and in the numerator, such that b into c becomes a rational number. The given surd and the expression with which it is multiplied to get a rational number are called rationalizing factors or conjugates of each other. So we are saying, if we have here, if we had b in the denominator, which is a surd, so we multiply this with c in the denominator to make b into c a rational number. In that case, b and c are called rationalizing factors of each other or conjugates of each other. So what does that mean? That if we multiply b with c, instead of getting an irrational number or a surd, we get a rational number as a result. So same is true for multiplying c with b. So we are saying they are rationalizing each other. So they are called rationalizing factors or conjugates of each other. Now let's see how do we do that? How do we do rationalization of surds with the help of some examples? So if we have a surd of the type a raised to power 1 by n, so we are saying nth root of a. Now if we multiply this with a raised to power 1 minus 1 by n, it becomes rational number. Let's see how it becomes. So if we have a raised to power 1 by n multiplied with a raised to power 1 minus 1 by n. So now using the laws of exponents, we know that this becomes equal to a raised to power. If these two are multiplied, their powers will get added as per the law of exponents. So we get 1 a raised to power 1 by n plus 1 minus 1 by n, and this 1 by n minus 1 by n cancel out each other and we get a as a result. So this is a rational number, because by definition we were saying the surd is nth root of a rational number. So a is definitely a rational number, and this is how we are able to rationalize a raised to power 1 by n. So a raised to power 1 minus 1 by n is a rationalizing factor or a conjugate of a raised to power 1 by n. Now let's take another example. We have something of the type a minus root b. Now we need to rationalize this. We have a plus root b as its rationalizing factor. Now let's see how it goes. So if we have a minus root b multiplied with a plus root b. Now we use an identity here which is of the type x plus y into x minus y, and we get, as a result, we get x plus y into x minus y is x square minus y square. So x square in this case is a square and minus square root of b, which becomes b. So now we get the result of this is a square minus b, which is a rational number. So we are saying a minus root b and a plus root b are rationalizing factors of each other, or you could say they're conjugates of each other. And the third one is if we have a surd of the type root a minus root b, then we need to rationalize it. We multiply this with root a plus root b. Again, if you see, we multiply root a minus root b with root a plus root b, and we again use the same identity, which is x minus y into x plus y is x square minus y square, which is square of root a is a minus square of root b is b. So we get a minus b as a result, which is again a rational number. So we say that these two, root a minus root b and root a plus root b, are the conjugates of each other. So why are we discussing these three is because most of the surds will be of this form, will be in this form, either of the form of nth order of a, or a minus root b, and or root a minus root b. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.